Hello, this is Engineering Mathematics 2. We are from SMJE1023. The topic is about application of first order differential equation. We are from group 8. My name is Naila Kimin and my friends is Muhammad Anif and Ati. The introduction. From a formal mathematical point of view, the differential equation is an equation that describes a relationship among a function, its dependent variable, and the derivatives of the function. Problem description. We choose question number 5. So the question is, an object falls through the air towards Earth. Assuming that only air resistance and gravity are acting on the object, then the velocity v satisfies the equation m dv over dt equal to mg minus pv, where m is mass, g is the acceleration due to gravity, and b is greater than 0 is a constant. If m 100 kg and g is equal to 9.8, ms negative 2 and b is equal to 5, kgs negative 1 and v in bracket 0 equal to 10 ms negative 1. Solve for v in bracket t. What is the limiting or terminal velocity of the object?
The methodology of this case study, we review the question first. When the velocity v satisfies the equation mdv per dt is equal to mg minus bv, where m is the mass, g is the acceleration, and b when it's above from 0 is a constant, and if m is 100 kg and g is a 9.8 milli per second square and b is a 5 kg per second, and if v when the time is 0, the velocity is 10 meter per second. Solve for vt and what is the limiting velocity of the object. The method used to solve the case study. Firstly, we must considering a falling object influenced by gravity and an air resistance proportional to the velocity of the object. There are two forces acting on the object. The force due to the gravity given by the weight, which in W is equal to mg, and the force due to air resistance, which is a negative bv. The net force is F equal to negative bv. As the follow of the picture FB given that indicate of the situations. Now, using a Newton's second law of motion, we perform a substitution for F is equal to ma. When a we convert to derivative of v, which means F is equal to m dv per dt. Then, when we include the situation of the object falling down, we get the equation is mg minus bv is equal to m dv per dt. Now we plus bv for the both side of equation, then it will make the equation is m dv per dt plus vb is equal to mg. To make the equation as the linear differential equation, we divide again both sides with m, then the equation will give dv per dt plus b per m multiple with v is equal to g. How to solve the linear differential equation? Firstly, in order to solve the equation, we must write the equation in standard form, which is dy per dx plus b bracket x multiple with y is equal to q bracket x. Next, we must determine the b bracket x and find the integration of b dx. After that, find the integrating factor, which is I bracket x is equal to exponent square root of integration b dx. So we must write the equation in the following form, which is d in bracket I bracket x multiple with y per dx is equal to I bracket x multiple with q bracket x. So we integrate both sides and we get the equation is I bracket x multiple with y is equal to integration of I bracket x multiple with q bracket x dx. If initial value are given, use the values to find the particular solutions.
So now we go with the way how to do the calculation. So first we're going to do a linear method where this question is a linear method. So m equals dv over dt equals to mg minus bv. So okay, first we're going to do is like we're going to point the we're going to bring them we're going to first differentiate first lah. So dv over dt equals to g minus in bracket b over m v. Then so the b negative b over m over v, we push it over that side, so it becomes d per dt plus in brackets b over m times v equals to g. So now we put the values here, which is dv over dt plus in bracket 5 over 100 in bracket v equals to 9.8. So these values are just from here, there it's constant values, where m equals to 100 kg, g equals to 9.8 ms negative 2, b equals to 5 kgs negative 1. These are the conditions which are constant, and v in bracket 0 equals to 10. So this is the main thing we have to think. So now we get back to the formula. So the question, then we get once we get 5 per 10, v equals to 9.8. so then we differentiate, we do some fractionalization. So 5 and 100, so we cut, so you get 1 and 20 down. So you got v dv over dt plus in bracket 1 over 20 bracket v equals to 9.8. So after that we will get about, so this is the wrong equation, so I cancel it off. So equals to get p over x, p in bracket x equals to 1 over 20. So this v value inside v is equals to px, while the qx is the outer value. So qx equals to 9.8. So we integrate the factor of p equals to e integrate 1 over 20 dt. So we will get as e t over 20. So now we get back down to the questions. So then we get dt d over dt in bracket e over t over 20 point v in bracket equals to 9.8 e t over 20. So these two values should be same. So then we go back to the normal, we push the t to this side. So what we will get, so we're going to differentiate this one. So how to differentiate, we have to push this here. So we got e t over 20 point v equals to differentiate or integrate, same also, 9.8 bracket e over t over 20 dot dt. Then we will get, then we follow this one, we integrate this one, we differentiate it. So we get about e t20 bracket v equals to 198, because we integrate the whole stuff here. Once we brought everything here, we have to differentiate, we have to integrate all of this. So we get 196 e t20 plus c, and then the values is v, so we have to push this that side. So once we push this there, so we get v equals to 196 plus ce negative t20. Then we just cut it off, cut, we get 10 equals to 196 plus c. So c is how much? So c equals, so how to get c? Very simple, this one you push there to get the value of c. The 196 we push to 10, so we got c equals to negative 186. So vt equals to 196 minus 186 e t20 negative t20. This where how we get this value is we get back to here. Understand? So this value, this value, right? How we get this value is here only, very easy. So we get this value, we merge it into on top here. So we get this value back. So the next is the limiting velocity. Limiting velocity is very simple. T equals to infinity. So lim t equals to velocity, vt equals to lim, and then in bracket 196 minus 186 e equals to t over 20. So t is infinity, so becomes 196. So limiting velocity is 196 ms negative 1. So this is the way we did the questions.
For result and discussion, the calculation we made has proving that the differential equation is an equation that describes a relationship among a function. It is a dependent variable and the derivative of the function. For this case study, here we get v is which is a velocity is equal to v bracket t is the unknown function, that time is t is the dependent variable. We must perform the equation into differential equation form in order to solve the unknown function. So we get from the result that v bracket t is equal to 196 minus with 186 multiple with exponent square root of negative 0.05 t, which is satisfied when m is 100 kilogram, t is equal to 9.8 milli per second square, b is equal to 5 kg per second, and when the v, the time is 0, the velocity is 10 meter per second. The limiting velocity of the object can obtain when we assume that time is equal to infinite, and these have shown us that the object only can reach its limit of velocity when the velocity reach 196 millimeter per second.
Based on this assignment 1, titled as Application of First Order Differential Equation, question 5, which is free fall, we learn more about ODE, which stands for Ordinary Differential Equation, which is a differential equation that contains one or more functions of one independent variable, as well as their derivatives. It is also an equation involving certain ordinary rather than partial derivatives of a function. Our aim is often to solve an ODE, that is, to figure out the function or functions satisfy the equation. We need to learn more about the linear method of ODE, which says that a differential equation is linear if f can be written as a linear combination of y's derivatives. That's all from us, and thank you.